today I said I'm going to discuss De Moivre's theorem, discuss the power of complex numbers using De Moivre's theorem, and also discuss the roots, extracting the roots of complex numbers using De Moivre's theorem. And lastly, I'll also do what we call exponential form of a complex number. So let's start. Okay, so the topic will be De Moivre's theorem. Okay, we have z to the power n is equals to r cos, it's the first time I use this one, r cos theta plus I sine theta, and this is to the power n. So this is equivalent to r to the power n, in bracket you have cos n theta plus I sine n theta. Okay, now did they say that where z is actually just equals to r cos theta plus I sine theta. So this is basically the polar form of a complex number. Remember last time we discussed that, we said that is r, angle is what is theta. So in expanded form, in a trigonometric form, it's like this. Okay, now and another thing that we'll use later, which I can just indicate now, we have what we call this. Basically what we have here, this z is actually influenced by what we called Euler's formula. So Euler's formula is e to the power ix is equals to cos x plus I sine x. So I'll just indicate that this is Euler formula from one of the most decorated mathematicians. Okay, now let's discuss the powers. Now we have everything that we need to discuss the power of complex numbers. So the power of complex numbers. Okay, like I said, we'll use De Moivre's theorem. Okay, now I'll use example to elaborate this one. So let's say you are asked to calculate 2 plus 2i to the power 6. So this is how I'm going to approach it. We start first by determining the value of r. R is equals to the magnitude of z, which is equals to the square root of 2 squared plus 2 squared in this case, and this is equals to root 8. Okay, and immediately after that, what comes to my mind is an angle. Theta is equals to tan inverse of y over x, where y is the imaginary part, so in this case is 2, and x is the real part, which is 2. This is equals to tan inverse of 1, and this is equivalent to tan inverse of 1. This is equals to 45. degrees, or if you want to use a radians, this is pi over 4. Okay, now we can write 2 plus 2i to the power 6. Now using the information that we have is the square root of 8 cos of 45. Here you can use any. Will be restricted only in exponential form, where we are forced to use radians. So this is sine 45, and then what is the power there? We can square everything, then we square this to the power 6. Okay, now this simplifies to the square root of 8 to the power what? 6. And then we have, according to the Moever's theorem, this is equivalent to 6 multiplied by 45 plus I sine of, this will be 45, 6 multiplied by 45 again. Okay, I hope I've closed everything. You can use the square brackets outside, is fine. Now, 8 to the power, root 8 to the power 6 will give you 512. And here we have cos of 270 plus I sine of 270. Now after that, you can use your calculator. Using your calculator, cos 270 will give you what? Let's check on my calculator. I'm getting 0. So it's 512. We have 0 here plus I. Now let's check sine 270. It gives me -1. Then from here we can conclude that this power will be equals to 512i, and this is negative. So now we have managed to determine this power using the Moever's theorem. Okay. So this is what will follow all the time when you are looking for the power. Okay. Now, what comes to my mind again, I said the Moever's theorem can also be used to extract okay, I want to check if I can start a new one. Okay. Okay, I'm done with this one, if you are comfortable. Oh, it comes again. Let me just cut it. Okay, I'll present it in detail. I'll start with the abstract, just to show you how to derive the equation for determining the roots. That will be the first part that I'm going to do. Then after that, we do the example. I think that always is important. You'll always find a question from this part. So I'll take my time to, there's one already in the next major test, which I don't know when we are writing. Okay, let's go back to our, okay, still have to erase this one. Okay, I'm done. Now let's do this one. Okay, I said the topic will be extracting roots. So now I'll present it. I'm not going to give you a formula directly. I'll derive it. I'm deriving the formula from scratch. Let's say if Z is equals to P, this P is the same as R, cos theta plus I sine theta, and we are given the equation Z to the power N is equals to W. Yeah, let's just call that, not omega, W. Then we are given that W is on itself a complex number, is R cos phi plus I sine phi. Okay, it can be anything, this one. You can use X, don't worry, it's just a symbol. Okay, where Z to the power N is equals to P cos theta plus I sine theta to the power N. Okay. Now, based on equation 1, so I'll say from 1, we have this case, we have P to the power N cos, I'm using the Moivre's theorem now, P to the power N, this one, using the Moivre's theorem, N theta plus I sine N theta is equivalent to R cos phi plus I sine phi. Then we close. So this is the same equation that we have there. We just that you have written it using what we have explained here. Still that equation on top. Okay. And also using the Moivre's theorem. Now, what do we deduct from this, what we have here? We can see that R is actually equivalent to P to the power N. And that we can also see that N theta is equivalent to phi, or we can write it differently as P is equals to the root, nth root of R, and theta is equals to phi over N. That's what we get from this star here. Now, how can we use that? Before I use that, you can see here we have sine and cos. What do we know from sine of cos? From what we have done under periodic function? We know that the period of sine theta and cos theta is what? Is capital T basically equals to 2 pi. So that is the period of sine theta and cos theta. Now combining everything together, what we have there, we can conclude that theta is basically equals to phi plus 2 pi k over n, where k starts at 0, 1, 2, 3, and the last term will be n minus 1. Okay, so that's what I have there. Now we have n. N, what is n? N is just a positive integer. So where n is a positive integer. Okay. Now to find a distinct, how do you write that? I think I wrote it wrong. To find a distinct or a different, don't like this small one, I want the bigger one. Okay, to find a distinct nth roots. This is the formula that you are going to use of complex numbers. This is what we use. We'll use remember that distinct complex number that we are looking for is what? Let's say z k is equals to n, the cube root, the nth root of r, open bracket, cos, let's say this is phi plus 2 pi k over n plus I sine phi plus 2 pi k over n. Then you close. Then this is the formula that you are going to use. I have managed to derive that. We are going to use that formula to determine the nth root. So you can start with the formula directly. You don't have to derive it. So if you have a way of remembering the formula, you can start directly from this formula here and solve the problem, whatever problem is given to you. Okay. Now, the solution that we are looking for, this nth root, the solution that we are looking for is nth root. Nth roots, how? If you present them on the Argand diagram or on the complex plane, the solution will be spaced. It will be spaced at 2 pi over n intervals. So you'll see that. Okay, now we can start with our first activity. We have the formula. Now, the problem that we have to solve is this one. I'll just write example or exercise. Using this formula, the one on top. I'm referring to the one on star. This formula to compute the third root of 1. So this is the question that they have asked us. I hope I should just underline so that you'll see that. Use this formula to compute the third root of 1. This is a complete question. Okay. Now the first thing that you're going to do here, you have to calculate R, calculate theta, and then write 1 as a complex number and substitute into the formula and determine Z0, Z1, and Z2. And the other thing that I forgot to highlight, but I highlighted on top, you should remember that K here, K is equals to 0, 1, 2, 3 up to n minus 1. Okay, n is a positive integer. Okay, now let's solve this problem. To open a new document. Okay, I'm going to solve that one. That is the first time I tried that one. Seems nice, but let's go back to our old one. I'll learn about it later on. Okay, remember, our intention here is to determine the nth root. They said determine using this formula, which I have to remember now. Formula to compute the third root of 1. So this problem is actually equivalent to solving z to the power 3 equals to 1. Okay, which is the same as z to the power 3 minus 1 equals to 0. This is equivalent to that. But now let me show you the steps that you're going to follow. I'll start by step 1. I'll determine R. R is equals to, okay, so this one here can be written as 1 plus 0i. So this means our imaginary number is 0 there. So we have 1 squared plus 0 squared there. This is equals to R. So this is equals to 1 basically. Okay, and then you look for the angle tan. So theta or phi in this case. Phi is equals to tan inverse of, now this is y over x, so it's 0 over 1, and this is equivalent to 0. Tan inverse of 0 is 0. Now 1 is a complex number. This is equals to cos 0 plus I sine 0, not theta, this is 0. Okay, now according to our formula, the nth root formula, we have z K is equals to, I'll just write the formula first, N R, the nth root of R multiplied by cos, this is phi over what? Cos phi over, I want to see if that's phi, cos phi over plus 2 pi k all over n plus I sine of phi over plus 2 pi k over n. I think you remember that. Over n, then we can close this. Now let's substitute. If we substitute, this is just 1, and our cos, and our phi is 0, so it's 0 plus 2 pi k, and our n is 3, we said third, okay, plus I the same thing for sine, the angle will be the same, 0 plus 2 pi k over n. Now remember here our n is 3. When our n is 3, it means that, remember, it's n minus 1. So if you substitute, these values will end up with 0, 1, and 2. So those are the values that k can take. K can take 0, 1, 2. Okay, so this means our solution will be Z0 equals to, this means wherever you see k, you substitute 0. So let's do that. So it's 1. If I substitute 0 there, I'll end up with cos 0 plus I sine 0. And then this basically just gives me the answer of 1. Immediately after that, I determine Z1. So this means wherever I see k, I substitute 1. So I have 1 cos of 2 pi over 3 plus I sine 2 pi over 3. And then you punch your calculator. From my calculator, my answer is minus 1 was 1. Minus 1 plus I root 3 over 2. Now the last one that you determine is Z2. Z2 is equals to, wherever you see k, I'll go up just to explain that part. Wherever you see k here, you substitute 2. So 2 pi multiplied by 2 is 4 pi. So we have cos of 4 pi over 3 plus I sine, because it's 1, I've already multiplied by 1, sine 4 pi over 3. Now, using your calculator, this gives you minus 1 over 2 minus I root 3 over 2. So now we have used De Moivre's theorem to determine the roots. So those are the steps that you are going to follow to determine the root. This type of question, if I'm setting, I usually put 1. Okay, so you must master that, and I'm expecting to find 1 in the major test. Okay. Now, the next thing that I'm going to discuss is exponential form. So, hello?
May you please go up? I want to say something.
Okay. Until when? We'll stop.
The question, where you wrote the question.
Okay. In the question, I said use the formula, or I can use the formula to compute the third root of 1.
Yeah, you see that one. How do you read that one which you underlined?
Which one? The one that I underlined?
Yes.
No, I said, I'm just trying to show you that this is an equation. they said determine the third root of 3. Okay, so this means they are actually asking you to, you are given this, they are asking you to determine the cube. This is what they're asking you to determine. Z equals to the cube root of 1. So most students, they make a mistake of just giving one solution, which is 1. And if you do that, you'll just get 1 mark out of probably 4 marks. Okay, so if you rewrite, this is just algebra here. There's nothing that I did that's complicated. If you have z to the power 3 equals to 1, don't forget about if and only. This arrow here means if and only if. Okay, maybe is that what you're looking for? This one, it means if and only if. Okay, and you can also write in English, if z to the power 3 is equals to 1, it implies that z to the power 3 minus 1 is equals to 0. You can read it like that. Okay. Can I move on to the next topic?
Yes, sir.
Okay, thank you. So I'm not going to erase, I'll just open new. No. Okay. So now what you do, when I started about the complex numbers, we discussed this form A plus BI. Okay, this is called rectangular form. Okay, and then we discussed this type R, angle, theta, and this is the polar form of a complex number. Now what we are going to discuss is the exponential form. Exponential form. Okay. Now we discussed Euler formula. So this basically is based on Euler formula, the exponential form. So we said e to the power I theta is equivalent to cos theta plus I sine theta. Now, in exponential form, z will be equals to r e to the power I theta, and this will give you a complex number. Okay, this is exponential form of a complex number. Now I can go there and write it is r e I theta. Okay, now remember, note Benny. Please note that theta is always in radian form, radians. So if you write in degrees, the question is not going to be marked. You lose all the marks. Always write theta in radians on when you are dealing with exponential form. Okay. Now, okay. Now let's deal with multiplication. Remember, we did multiplication for polar form. It will be similar, something similar to that. Okay, let's say we have Z1 equals to R1 e to the power I theta 1. Is someone who want to ask question? Z2 is equals to R2 e to the power I theta 2. So Z1 multiplied by Z2 is equivalent to R1 multiplied by R2. Let me address this one. I don't see the hand, so no one I want to ask a question. Yeah? So that's what I assume. So switch off your mic. Okay, R1, R2. R1, R2. So we have e to the power I theta 1, e to the power I theta 2. This is equivalent to R1, R2. Because the base is the same, we add the index. This is I theta 1 plus theta 2. So this is how we add complex numbers in. Okay. There's a question. You can ask the question, Riba.
So it's not a question. Can you please like go to the top of the slide? Didn't see
Okay.
something that I missed.
Okay. Yeah, we can switch off your mic. You should write your name, guest, J.I. guest. You should switch off your mic also. Or I'll switch it for you. I can see you don't know how to switch it off. Okay. Okay. So when I started, if I repeat, I said we started with this form, which is x plus y, I, or can be a plus bi. This is called rectangular form. Then we dealt with polar form, which is r angle theta. Then we dealt with, now we are busy with exponential form. So I said the exponential form, basically we first have to discuss Euler's formula, which is e to the power I theta is equals to cos theta plus I sin theta. Now I said the complex number in exponential form is z equals to r e to the power I theta. And then I said you should note that at all times make sure that your angles are in radians. If you fail to do that, it's not going to be marked because this is important. It only exists in this exponential form in radians. Okay. Then I discussed multiplication. Under multiplication, I said if you have Z1 and Z2, then I define what they are. You multiply two radius, and then you multiply those two exponents, e to the power I theta. But knowing the laws of exponents, we can rewrite this as our base is e, we have common base, then we add the index. Then you take I out as a common factor. That's basically what you have done. Similarly, Z1 divided by Z2. This is equivalent to R1 divided by R2. And we have e to the power I theta 1 all over e to the power I theta 2, which is equivalent to R1 over R2. The base is the same, so it's I. We take I out as a common factor. We have theta 1 minus theta 2. So this will give us the division. So we're on page 5. Now let's take one example. Let's say you are given, there's somewhere where we have computed the powers using De Moivre's theorem. Let's say I ask you to compute 1 plus I to the power 19. You can see you cannot expand this, it's very long, in exponential form. The fact that it contains power, this means you are forced to use De Moivre's theorem. Okay, now R is equals to 1 squared plus 1 squared, which is equals to the square root of 2. Now our angle, which we can just use theta, is equals to tan inverse of 1 over 1, which is equals to pi over 4. Okay, now 1 plus I to the power 19 is equivalent to, now I'm going to write it in exponential form, the square root, this is my R, e to the power I pi over 4, everything to the power 19. Okay, that's what I have. Now I'm going to simplify this, the square root of 2 to the power 19, okay, multiplied by e to the power I 19 pi over 4. Now I'm going to simplify this. So this is the same as 2 to the power 19 over 2, e to the power I 4 pi minus 3 pi over 4. And this is equivalent to 2 to the power 19 over 2, e to the power I 3 pi over 4. So this is my solution. I end there. So I have written it in what? In a complex, in exponential form, in a simplified form. So if you like, this one you are allowed to punch your calculator, 2 to the power 19 over 2. Hello?
Why did you say 4 pi minus 3 pi over 4?
My complex number is in the first quadrant, isn't it? The given one.
Okay, then is it, yeah?
Yeah, that's the reason why I wrote it in that fashion.
Okay.
Okay. Now, immediately after we have discussed the powers, immediately after that, what comes to my mind is how do I do the roots of new? Let me address this. I'm coming now.
Guys, if we have repeaters in our class, may you please send the slide because it's starting like this, yo.
Okay. Now I'm going to do the formula for root of unity using, we are going to solve the same problem that we solved using the complex form. I'm not going to go to a new page, I'll just extend this one. Okay. So I'm going to solve that problem with the, what was the problem? They said determine the third root of 1. They said using the formula. So So I said this problem is equivalent to z to the power 3 equals to 1, which is if and only if this is the case, z to the power 3 minus 1 is equals to 0. Okay. And I'm just going to do it step by step, don't worry. So we determined our r. First, our r is equals to the square root of 1 plus 0, 1 squared, and we square this is equals to 1. This comes from where? We know that 1 can actually be represented as a complex number. It's 1 plus 0i. Okay. Now we write this as 1 is equals to cos 0 plus I sine 0. Okay. Now I think we have all the information that the angle theta is equals to tan inverse of y over x. Our y is 0, so it's 0 over 1, and this is equals to 0 when you punch your calculator. Now let's see. Now in a complex form, in exponential form, zk is equivalent to n r e to the power theta plus 2 pi k all over n I, and k still starts from 0 up to n minus 1. Now let's substitute and see. In this case, we are looking for what? Let's start with z0. Our n is 3. Our r is 1. E to the power, our angle in this case is 0 plus 2 pi of 0 all over n. Our n is 3. All over 3i. And this we just conclude is just 1. It's nothing but 1. Now z1 is equals to, you can just write this as 1 e to the power 2 pi over 3i, and that's the solution, equivalent to e to the power 2 pi over 3i. And then z2 is equals to 1 multiplied by e to the power 4 pi over 3i, equivalent to e to the power 4 pi over 3i. Then we are done. I said in exponential form. Then you just stop in exponential form. We don't need to convert it to other forms. Then you're done. That's the solution. Okay, any questions? Okay, I'm done actually. This is what I wanted to present on complex numbers. But there's a certain question that I like. I think let me give it to you. I'll just do it mentally. I don't have it somewhere. Okay, let's just take a new page. Okay, we said cos theta plus I sine theta to the power n is equals to cos, let me put r, So that's what we said. Just want to write the Moivre's theorem and then change the conditions. So it will be r to the power n, okay, cos n theta plus I sine n theta. Now I want to expand. If r is equals to 1 and n is equals to 2, I want to write this. What will be this? So it's going to be cos theta plus I sine theta to the power 2, and this is equivalent to cos 2 theta plus I sine what? 2 theta. Now, in that question, what I'm going to ask you, I will ask you to prove that the left-hand side is equals to the right-hand side. So you have to simplify the left-hand side to show that it's equals to the right-hand side. So to do that, you borrow from grade 10, not grade 10, grade 6. I'll just do that because we have not yet done the binomial theorem. This can be solved using binomial theorem. This is what I learned in grade standard 4 many years ago. So these are actually the coefficients. So basically, if we have a plus b squared, this will be equals to a squared plus 2ab plus b squared. So this will be represented by this one. These are the coefficients of a and b here. Okay, and this one that we have on the third one is actually a plus b to the power 3. Your answer will be a to the power 3 plus 3a squared b plus 3ab squared plus b to the power 3. So with this, I have a powerful tool that I can use to simplify this type of equation. But once I have done with you later on the binomial theorem, then you can also borrow from the binomial theorem. Okay, so basically that's what I'm going to use for now. Okay, so let's do that. Now on the left hand side we have, let's just expand it normally. It's going to be cos squared theta plus 2i cos theta sine theta plus I squared sine squared theta. This will give you your LHS. Now let's look at the RHS. Your RHS, this now we have to borrow from what we call the compound angle. We have cos 2 theta plus I sine 2 theta. So from my knowledge of trigonometry, the first one I can write it as cos squared theta minus sine squared theta plus I 2i sine theta cos theta. And that's it. Now, how many terms do I have there? It's 1, 2, 3. Here is 1, 2, 3. So it's the same. Now, to get the equivalent of this, you must use your knowledge of complex numbers. We know that root minus 1 is equals to I, and I squared is equals to minus 1. So substituting I squared equals to minus 1, then we can conclude that LHS is equals to RHS. So I have seen them writing this QID. So is that we have proven that the left hand side is equals to the right hand side. So this problem can be extended to n equals to 3, n equals to 4, n equals to 5. Okay. And sometimes I can ask you to prove that. Let's take n equals to 3. I think we'll be able to do that. For n equals to 3 is going to be what? We have a situation where r is equals to 1 and n is equals to 3. So this will give us cos.
Sorry, sir.
Hello?
Can you please scroll up a bit to the previous question that you were doing?
Okay, is it okay?
A bit down. I want to compare the answers.
Or you're comparing where I put I, ne? Yeah, let's see. Yeah, he's here.
Okay, so say how is... Oh, no. Oh, no, I see now. No, I see. I was confused because the right-hand side wasn't written in the same order, so I got confused. I see.
Okay. Okay, thank you. Okay, now the main reason I'm doing this one is a little bit complicated than that one. That one is straightforward. So this is to the power 3. So this will be equals to cos 3 theta plus I sine 3 theta. So what remains only here is for you to prove that the left hand side is equals to the right hand side. You can take anyone. Let's take RHS first. So if you take RHS first, cos 3 theta plus I sine 3 theta. So this is equivalent to cos 2 theta plus I sine 2 theta plus theta. Now what remains now is to expand this. We know that cos 2 theta cos theta minus sine 2 theta sine theta plus I. Now we expand this one. It's going to be what? I'll put bracket sine 2 theta cos theta plus cos 2 theta sine theta. So we have expanded. So I hope you still get that. Now we have to simplify cos 2 theta. Cos 2 theta is the same as cos squared theta minus sine squared theta cos theta minus 2 sine squared theta cos theta plus I. Let me put it directly. I was supposed to close here. 2I. Okay, here from here we are going to get from sine 2 theta, we're going to get 2 sine theta cos theta, which will end up being 2I sine theta cos squared theta. Okay, plus I, that's the I that we have there. Now we have to simplify this one here. What do we get here? I can write it mentally. I don't know if you'll see it. Because cos 2 theta is similar as cos squared theta. So I'll have cos squared theta sine theta minus I sine to the power 3 theta. Okay. So this is just expansion of what we have on top. I think you can do it on your own. Now, once you reach this point, you have to expand and group the like terms. Let's check the like terms that we have. Okay. Let's check the i's also. I think it's going to be complicated in terms of, did I respect I? Let's check. The like terms. Okay, I can see cos to the power 3 theta for the first one. We have minus sine squared theta cos theta. Where do you see that? Is this one. So I have minus 3 sine squared theta cos theta. Now let's check the ones containing I. This one and this one, they give me 3 again, plus 3 cos squared theta sine theta minus I sine to the power 3 theta. Now I have proven the right hand side. Now what remains now is for you to prove that the left hand side is equivalent to this. So that's what we have to do next. Okay, can I do the left hand side? This one you can do on your own. The most important part is for you to move to this step. Once you reach this step now, you only use your knowledge of trigonometry. This is, once you move from here to this one, then from there, if you know trigonometry, you'll be able to prove it. Okay. Now, I want to go to prove that one. It's going to need Pascal triangle, the one that I've just discussed. Okay. Okay, LHS. Okay, I think the darker one will be preferred here. LHS, we have cos theta plus I sine theta to the power 3. Okay, so here I'm going to use Pascal triangle. I hope you'll remember that. So I said it's 1, 1 and 1, 2 and 1. So how do I get this? This is how you do it. 1 plus 1 is 2. 2 plus 2, this you add this will give me 3, 3, 1 and 1. So I am going to have cos to the power 3 theta plus 3 cos squared theta I sine theta, okay, plus 3 cos theta I squared sine squared theta plus I to the power 3 sine to the power 3 theta. Okay, so now what remains now is to use the concept that I squared is equals to minus 1. So let's use that. Immediately after that, we'll get the same solution. So we have cos to the power 3 theta plus 3 cos squared theta I sine theta minus 3 cos squared theta sine squared theta minus I sine 3 theta. So now we have proven that LHS is equals to RHS. And again, it's done. Okay, this will be the end of the class. Any questions?
No questions. Just wanted to remind you about the slide. What means you said you're gonna upload them on
No, I have them now. I managed to download them. They are in my computer. The only thing that remains is to take them from my computer to my cell phone.
Yes, please, sir.
So I can send them via WhatsApp. We will have access to them. Eh?
Yes.
Okay, no problem. Okay.
Sir, what textbook are you using, sir?
I'm not using textbook here.
Okay, so like, say, if you want to go practice questions, where can we go, sir?
Okay, yeah, in your textbook is there. For complex numbers is there in your textbook. The engineering, higher engineering mathematics.
Okay, wait. First, so say
Okay,
all the
I
work we've
have,
been
I have
doing.
let's check it here while we are still here. No? This is higher engineering mathematics. This is an old version. I don't have a new version. Is there complex numbers? Let's see. Yeah, 241. Can you see that?
Yes, sir. So
Yeah.
all the work we've been doing is in this book.
Yeah, you can see the powers of complex numbers, roots of complex numbers, exponential form of a complex number. You might find that the little bit is not there, but the 95% is there.
No, sir, I'm not just saying this section of work. I'm saying like all the work from the beginning.
No. This textbook doesn't have some concepts, so I'm forced to use different textbooks. Here I have 5 textbooks here at home that I'm using. So the best thing that you can do, let's say study guide. No? Let's say South African Engineering Council. No, not this one. No, I can take anyone. Let's just take 2019. Subject 5. Okay, in your study, this is your study guide. This is the most important document here. It actually tells you which topics you are going to use. Okay, let's just scroll down. I'm looking for where they have a textbook. Okay. This is your lesson plan. Yeah, this is the I'm coming. This is the prescribed textbook. And they are recommended textbook. So you can also use recommended textbook like can you see here? And this is not only the recommended, there are others also. You should check on also on your notebook. On your notebook, there should be what we call at the last page. Oh, you don't have that book for calculus. The reason I didn't give you that book, I have given it to another lecture to edit. So on the last page of that textbook, I can just put the last page also on my tutor. So the last page you will find what you call references. References, this means what I have used to write the notes. You'll find different textbooks that you can use. Just go to the library, you look for those textbooks and you work through them. And some of them you can find them on the internet actually. Okay. So, but this document is the most important document. It tells you what you must do and what you must cover. Let's say, for instance, no, not geometry. Geometry I'm not going to cover. You see under complex numbers. This is what you have to cover. You should solve the equation, represent the complex number, solve the quadratic. These are the points. If you can do all these points, and then the more complicated problem of whatever is represented here, you'll be able to survive. So this means we can use any textbook that contains this content. What I'm trying to say is that you take the study guide, unit 3, you look for textbooks that contains all this work. Then that's how you'll survive. Okay?
Okay, sir.
Thank you. I want to stop the recording, otherwise I'll miss it. Okay.